Hi all, welcome to my class. In this video, I will cover up a theory about the CNC lathe. I hope you will watch this video to the end and you will get better understandings about the CNC lathe machining process. I believe all of you had gone through a module about the lathe machines. You also have fabricated several parts using a manual lathe. I think with your basics in manual lathe, you will easily to understand concept of lathe machining process. So further ado, in these chapters, we will cover up introductions to two-axis CNC lathe. So for CNC lathe, the Koku is Koku number 7. So before this, I think you already know and have an experience handling a lathe project. So this is several example of lathe projects that can be produced in a CNC lathe. And the process, the cutting process, I think you have an experience using a manual lathe to cut the materials. But in CNC lathe, they are quite different using a tools and setup for the machines. So what is CNC for? CNC is stand for computer numerical control, which means that computer control the movement of the machines. And before you are using or handling a CNC machines, you need to apply a PPE, that safety glasses, safety shoes, and earplugs if necessary. And follow a SOP, machine maintenance, machine setup, programming, graphic checks, dry run, and actual cuts. So what is the advantage using a CNC? So there are several advantages that have when you're using a CNC. Accuracy, the modern CNC machines are capable to perform accuracy within a tolerance of 0.025 to 0.005 millimeters. And reliabilities, the machines do not require much attention as a conventional machines, allowing the operators to perform another jobs while the CNC machine is running. And the repeatability for the CNC machine is efficient to control its accuracy and productivity. The goal of the industries has been to produce a better product at competitive and a lower price to gain a bigger share of the market. And last is a safety. CNC machine most have a safety control guard that can protect operators from injury when the accident occurs on the machines. So we have several types of CNC lathe in PSDC, and commonly a CNC lathe has a two-axis slant back CNC lathe. So you can see pictures over here that what means by the slant back is the slants of a turret movement. You can see this is a turret, and the turret movement going down using a slant back. There are pro and con using this slant back. The advantage of this kind of machine, the chips will not stuck into the beds because it has an angle. And this is a machine components of a CNC lathe. You can see we have two turrets over here, and then main spindle. We have headstocks, main drive motor, chucks, back, tailstocks, a CNC controller, a monitor, and a carriage. So a component of CNC machine consists of a machine spindle. So in the machine spindle itself, it has several parts. Chuck or collets. You can see over here we have chuck or collets, and then it has a draw tubes, a bearing, spindle shaft, and then non-contact encoder rings, sprockets, non-contact encoder rate heads, adapters, hydraulics actuators, coolant collectors. For control, unclamp and clamp the 3-jaw chucks, we're using the foot pedals to clamp and unclamp the 3-jaw chucks. So inside the spindles, so we have a machine's draw tubes. So the function of draw tubes is to lock and unlock your 3-jaw chucks. When the hydraulics mechanical cylinders has been functions, it will push and forwards and backwards to unlock your 3-jaw chucks. So bear in mind that our 3-jaw chucks force are using a hydraulics. Whatever you do, make sure your finger are not in the 3-jaw chucks. When it closed or unclosed. So next is our 3-jaw chucks. So 3-jaw chucks, we need to set the force of the clampings of the 3-jaw chucks. And I think beside of the machines has the graphs, how do you to set the 3-jaw chuck force by pulling off a hand wheels besides of the side of the machines. And this is the components of machine chucks that we have over here. We have a chuck body, wedge plunger, master jaw, soft top jaw, T-nuts, tip conveyor, draw nuts, draw tubes, plunger nuts, handle, and chuck wrench. So another part of a 3-jaw chucks that we have a soft jaw rather than a hard jaw. If let's say that the parts need to be clamped after machines, you'll need to use a soft jaw to clamp it. So for that, you need to turn the soft jaw to the similar diameters of the part that you need to clamp, or turn the diameters or turn the profile according to the part that you need to be clamped. So for that, you need to use a boring rings to clamp, to lock the jaw before you boring the soft jaw. And mounting jaw is a very serious part that you need to put much attention on it. So in this matter, you need to check the serration pitch on the jaw and on the chucks. You need to have you need to check serration pitch when you clamp the jaw to the chucks. If let's say you clamp the jaw not evenly, so the rotations of the chucks is not even and cause vibrations to the machines. The next component is a machine turret. You may see here the turrets of the machines has fully loaded with the tools. So for the machine turrets, we need to understand which of the numbers of the machine turrets that need to be separate when we do the loads the tooling to the machine turrets. So to load the tool to the machine turrets, we need several attachments that need to be used to mount the tool to the machine turrets. That we have angle blocks or the sleeve. So if let's say that you want to put OD tools on the machine turrets or ID tool on the machine turrets, you'll need to use this attachment. Next component will be a machine stock, tailstocks. So tailstocks, we need to use tailstocks whenever that we turn a material, a long materials, and need to support the materials from overhanging around. So next we have a CNC controller, a machine console. We have several type of controller in PSDC. For CNC Lathe itself, we have around 4 type of controller. We have Fanuc controller, we have Herco controller, we have Okuma controller, and we have also Mazak controller. So different controller come with a different type of G code and M codes. But the ISO code is the same, but they have several G code and M codes that we need to understand before we using the machines. So for the controller, you need to key in the program or insert the program. It depends on the purpose of your using the machines. If let's say you need to manually key in the program to the machines, you can manually key in the programs, or maybe you prepare the programs in the computers and transfer the programs using a thumb drive or maybe using a TP cables. You can use it. Okay, so you may use flash cards, maybe load and unload the program using the USB drive. Okay, so the CNC systems is start with the input device. So come to the MCU, data processing units, and control loops units, and then move to the motions data, drive the systems, machine tools, miscellaneous functions, and send to have a feedback systems, positive or velocity feedbacks. So to move the machines, we need accurate things. In this CNC machines, we are using a servo motor. It's a replacement to step motor and ordinary AC and DC motor. It functions to move the ball screw. This motor has an encoder. So ball screw is a replacement of a lead screw. Its function is to make the machine stable, to move the machine table, and the advantage of the ball screw is to reduce the frictions. So maybe based on your experience before we're using manual lathe, you have seen in front the manual lathe are using a lead screw. So when you move the carriage, you can feel the backlash of the carriage. So in a CNC, it's a difference because we're using a ball screw. We control the accuracy of the machines. So I think we have a 5 minutes exercise that you may do exercise. You can scan this QR code, and I see you back after 5 minutes of this exercise.